For the upcoming Sloan Science Prize for YouTube, in collaboration with the Independent Media Initiative, or IMI, we've been tasked with designing and building an award. But this is not some boring static trophy, because we've built it with a hidden mechanism inside. Let me demonstrate. Firstly, note the trophy is out of balance, and that it says Sloan in the middle. And now let's give it a spin. When it settles back into its out of balance position, the logo has changed from Sloan to the IMI logo. And if we spin it again, you will notice it then lands back on the IMI logo. So, how does the mechanism work? Is it possible to predict which logo will show after a spin, and how did we make it? The mechanism will be fitted on the inside of this large ball bearing. If you're already wondering how the mechanism works, your first hint is that the bearing needs to be free. So I cleaned out the factory grease and applied a light lubricant instead. This lump of 316 stainless steel will become a ring which will contain a critical part of the mechanism. To turn this into a ring, the obvious option is to drill and bore a giant hole through the middle, but I thought this would be boring and wasteful, so instead I opted to mount it on the milling machine and use a milling cutter like this one to remove the central part. To be honest, after about 6 hours of milling, I regretted this decision, especially because the cutter wear cost more than the material I saved did. I then cleaned up the ring in the lathe. When holding a piece of metal like this in the chuck, it's important it sits slightly away from the chuck jaws, so there's clearance to run the tool off the end of the workpiece. To do this, I found this PCB material is uniform in thickness and easy to cut, and temporarily attached to the chuck jaws. Masking tape helps protect the inside. The outside of this stainless ring is designed to fit neatly in the bearing race. To measure this, I use a 100 to 125 micrometer. Now, by the way, the hidden mechanism inside this micrometer thimble is, in my opinion, absolutely ingenious. It displays the 0.1mm increments all the way through to the full millimeter, even though each revolution actually only moves the spindle by half a millimeter. It does this by adding or subtracting 0.5mm to each number underneath the thimble on each rotation. Anyway, back onto the current hidden mechanism. I machined the ring slightly undersized so it would be a nice snug fit in the bearing. This leads me onto an interesting problem with close tolerance large diameter fits. The ring is a lovely loose sliding fit in the bearing, but it's very difficult to initially fit in. The reason for this is because of a slight angular misalignment, which increases the effective diameter of the ring. If I gently apply even force to both sides of the ring, you can see how easily it slides. But if it's even imperceptibly misaligned, I can put my entire body weight on it and the ring will just jam. In this case, the easy solution is just to allow more clearance between the ring and bearing. Within the stainless ring, I intended to machine 2 compartments to contain some weights. In this 3D printed example, you can see two ball bearings, which will be used for these weights. These compartments will be hidden from view once the trophy is assembled, but the idea here is to allow the weights to move, and this is the first element that allows the mechanism to work. These weights will create an imbalance in the ring, but if the trophy is flipped upside down, the weights move to the opposite side of the channel, which flips the imbalance to the opposite side of the ring. At least that's the theory. In practice, we found the ball bearings weren't heavy enough to overcome the bearing friction, and when we calculated the required weight to overcome this, we realised we needed denser material for the weights. Lead shot came to mind. The higher density of lead and the small ball diameter increases the packing efficiency and therefore the weight imbalance. We 3D printed a variety of different compartment geometries to try, and experimented with different ways of using the shot, such as packed into these sliding packages to help force an unequal weight distribution. We also tried some completely different ideas, such as hiding the moving weights behind the large Sloan logo, which formed the main shape of the trophy. We also tried using magnets in a variety of different configurations instead of weights. I thought perhaps we could use repelling magnets around the majority of the bearing, with magnets that attract in two positions. But here you can see the problem with that idea. Between two repelling magnets, a stable position exists that isn't one of the two desired options. After a variety of iterations with thousands of spins, we arrived at a final solution we were happy with. It worked with the lead shot, but we ended up changing this for tungsten carbide shot, which is even denser. With the final geometry of the compartments nailed, I mounted the ring back onto the rotary table and machined them with a woodruff cutter. 316 stainless isn't the easiest to machine, so I ran the machine slowly, and I made sure to keep the workpiece moving relative to the cutter at all times to avoid work hardening. We also chose stainless steel for the main trophy shape, but we had a tight timeline to work to with this project, and we couldn't buy stainless steel plate in time, so we had no choice but to use Alistair's secret stash of experimental alloys. Having spent much of his professional life developing metal alloys, he has some weird and wonderful metals, and in the case of this stainless plate we had no idea what it was. I can tell you one thing though, it made the 316 feel like cheese. Hazel and I machined the front and back on the pantograph, and I cleaned up the machine surfaces with some good old hand filing. Now, these trophies are for the Sloan Science Prizes for YouTube. The IMI has partnered with the Alfred P. Sloan Foundation to help support the creation of YouTube projects with a science and technology theme. Applications close on September the 30th, so if you are thinking about starting a YouTube channel, or you already have one and you're looking for support for a project idea, make sure you apply for this amazing opportunity. The link is in the description if you're interested. After the debacle of a broken tap, I decided to tap the holes by hand, which will accept the countersunk bolts to hold the front and back on. To engrave the mini Sloan name and the IMI logo, I used this 0.3mm milling cutter on the pantograph. The working principle here is very simple. The logos are engraved onto the same brass plate, which can slide within the groove cut within the stainless plate. This works in tandem with the weight imbalance mechanism to change the displayed logo depending on the orientation the trophy settles in after a spin. After a quick clean-up with some emery paper, the finish of the pantograph looks good, but since these logos are quite small, some additional contrast will help them to stand out. To do this, I used brass blackening fluid. Of course, the bearing needs to be mounted onto a base plate. This is a bit challenging because the bearing can't be drilled or soldered, so I opted to use a retaining compound to bond it to a brass block, which can be bolted to a base. We'll be making several of these trophies in the coming weeks, and we've got some design improvements in mind, but for this prototype, a base made from cherry wood will do nicely. These are all the parts of the trophy. It really is quite a simple mechanism. The stainless ring slots into the centre of the bearing, and the first stainless plate is bolted in place. The tungsten carbide shot can then be tipped into each cavity. The second stainless plate is bolted in place, and the tungsten carbide shot is now fully contained. The sliding plate is placed in the slot before the final cover plate is screwed in place. The final mechanism demonstrated a 90% success rate where a fail was considered as not stopping in either of the two desired positions. We will improve this number further on the final versions, but I think this is enough to demonstrate the principle. We caught up with last year's award winners Zyla Foxlin and Joe Posner, who will both be receiving a trophy, to see what they thought, as well as the president of IMI, Stuart.
The IMI award that sits behind me, like we've put a lot of thought into the meaning behind it, in addition to like its beauty and its craft. And so we wanted to mirror that in the Sloan Prize. I wanted it to be a kinetic award, but also a kinetic award that lasted for decades. So that meant that like it shouldn't be battery powered. It shouldn't have very many moving parts. And the moving parts should be like very well engineered and very well machined.
Here it is. Hopefully you can see that, right?
Does it? That is so rad.
Yeah. So it's designed around this large bearing. But
you guys custom machined this whole thing.
Yeah. So everything's machined in-house on manual machines. Mostly manual. We've got a pantograph, which helps to kind of like bring a little bit of almost CNC.
I think a pantograph counts as manual.
So it's weighted. So the idea is it will sit in the upright position.
Nice.
But then the idea is to spin it. You can see, but now the text is now
changed. Whoa!
That's how it's supposed. Yeah, it.
So it's just like changing.
Oh,
you can see the text has changed.
Yeah.
Yes, we love it.
Whoa!
That is so cool.
Is it on its own bearing inside of it, or is it geared? No, it's on its own.
Yeah, if you look now on the reverse side of the trophy, that's now got the text that was previously on the front. But if you look a little bit closer, you can actually see all the way through that.
Oh.
So that's part of the mystery of how the design works.
It teleports from one side to the other.
The concept is that there's two stable configurations. So the S can be in one of either of two configurations. And as you rotate it, it will randomly choose one of those configurations based upon friction. And they've engineered it beautifully so that the internals will help it settle into that stable configuration. And what's beautiful about it is that if it chooses one configuration on one side, if you look at it from the other side, it will always have the inverse, so to speak.
Let me just tell you, as someone that's never actually won an award that is made of anything besides paper, this is amazing.
Yeah.
I'm so excited.
I think it is a really good idea. Actually, originally it's Stuart's idea to kind of bring in this mechanism into otherwise it's sort of a boring thing, isn't it? A stationary sort of award, but hopefully this makes it a bit more interesting and fun.
I didn't expect it to be kinetic. Like I didn't expect it to be but now like as soon as you said it, I was like, oh yeah, that makes so much sense. That's so cool.
Is there something that you know about in the world or another physical like mechanism like this that you were basing it off of? If you guys are PhDs in engineering, I feel like you must have a lot to pull on in how to come up with this. And I'm just very curious. Like obviously you guys are also just great problem solvers. So maybe it's not. I just wanted to ask.
Actually, no PhDs required. The first thing I thought of was an hourglass. So literally just a sun timer, and then thinking, is there some way you could use that because it's going to change where the center of gravity is over time? to then move it into the trophy and do something similar there. So we kind of went from sand to then ball bearings, and then back to something closer to sand again when we figured out what works best for the weighting. But yeah, no, nothing complicated at all. Literally just like hourglasses.
Yeah, no. But I feel like that's so cool. And anyway, I love it. I feel so lucky to get to be part of this. Thank you guys.
Joe and Zyla seemed enthused by the idea, so I think we can count it as a success. A big thanks goes to Stuart from IMI for including us in this project. Now, if this award is something you're interested in, please do check out the link in the description on how to apply. It's an incredible opportunity, so don't miss out. Thanks for watching, and we'll see you in the next one.